Hi, so this video is going to go over the proportionality worksheet. So this starts on page 23 in your worksheets. So one thing after reading the text that you should have noticed is the idea of proportionality, and also this was, I believe, objective 3 in this section, that you should have understood the following equation, right? So if we know that x and y are proportional, right? Then we know that that we must have y equals k times x, where k is a constant and called the constant of proportionality. Right? So if we want to know if two things are proportional or not, right? One way to know for sure is this must always be true, right? If two things are proportional, we must be able to set this up in this type of equation, right? So in this worksheet, we're going to work through some examples of where proportionality could exist, right? So like maybe in your job or in your life. So these are the directions. The first thing we're going to do is we're going to determine which of the following quantities are proportional, and then also look at if they are proportional. We want to show this relationship using an equation, and then after, if we're able to express everything in an equation because it's proportional, then we also want to specify the units of the constant of proportionality in your equation and identify the name of the constant if we know it, right? So what would we refer to that as? So we're told that this first one has been done for us, right? So if we compare the property tax to the appraised value of our home, right? So in other words, what you want to think in your head is, if I double my property tax, does that mean my appraised value of my house doubled, right? Always. If I triple my property tax, does that mean my appraised value of my house will always triple, right? Or are those going to go back and forth? So if I multiply one by a constant, is the other going to be multiplied by that same constant also, right? So if you think about that for a little bit, right, how that works, yes, that's proportional, right? So if I double my property tax, that means my appraised value of my house doubled, right? Or you could go vice versa, right? If I double my appraised value of my house, then my property tax is going to double. So this is the equation that we could get, right? So we could have tax equals k times value, right? Where k is my constant of proportionality, right? And then this next row, so we just set up k equals, and then took my property tax, and compared it to, or divided by, my house values, right? So if you notice, the units that my taxes are in are going to be in dollars, and also the house value is going to be in dollars. So in mathematics, right, when you take one unit divided by the same exact unit, these units cancel out. So we refer to this as unitless, right? So if you take dollars divided by dollars, the dollars cancel out on the top and bottom, right? And so we don't have units then for k, right? The units cancel out. So if you know this, right, this is called the tax rate or the mill rate, right? That's what this concept of proportionality is referred to in the tax world, right? All right, so then what I would like to do next is go down to this box near the bottom. I think filling this in will help us in looking at the other examples. So this is what we call the intuitive definition, right? So it says two quantities are directly proportional if, when you double one quantity, so you would fill this in, it would be the other also must double. Right. So as I was saying before, we can use this intuitive definition to think about the situation that we're in. Is it going to be proportional or not? Right. So number 2, we're comparing the population of a region to the area of the region. right? So in other words, if we look at some region that's 10 miles squared and we get that population, then if we look at another area of a region that's 20 miles squared, so double, will the population double? And the answer is no, right? So no, we could say the area does not double if the population doubles. Right, so this was looking at the variables in a different order than I was, but that's okay too, right? So turning this around, if we also think about if I double the population, does the area double? And the answer is no, right? And vice versa would not necessarily be yes, right? So this idea would not be proportional, right? It wouldn't make sense to use proportions for this situation, right? And it's helpful to know when it makes sense to use proportions and when it doesn't, right? So that's the purpose of this worksheet. So then number 3, we have the volume of the water compared to the weight of the water, right? So in other words, if I double the volume of water, will the weight double, right? Or if I double the weight of the water, will the volume double? And if you think about this for a minute, this would be yes, right? So for every 1 cubic feet of water, that's going to have one specific weight, right? So 1 cubic feet of water is going to have some weight in pounds, right? So if I double this, have 2 cubic feet of water, this will also double in weight, right? So if you think about that phenomena, that makes sense, right? That would be proportional. So that would be yes. And the equation that we could represent here is we could say the weight equals K times the volume. Right? And if we solve for K, right, if I divide both sides by volume, we would have weight divided by volume equals K. So when we have a ratio set up from weight to volume, this is referred to as density, right? So so density is comparing weight to volume, right? And typically the units that we would use here are kilometers per meter cubed, right? That's a common unit for density, right? So then now look at number 4. So number 4 says the population of New York City compared to the population of New York State, right? So in other words, what you want to think is if I double the population of New York City, will the population of the state also double? It could, but in general, that's not always going to be true, right? That's not going to be proportional. One doesn't cause the other to double also, like guaranteed, right? So this would be no, right? This is not proportional. So no, we could say if the population of New York City doubles, the population of New York State does not have to double also. Does not have to double also. Right? Good. Alright, so the number 5 is comparing number of babies born in a year compared to the number of women aged 12 to 45. Right? So if I double the number of babies born in a specific year, would I expect to have double the amount of women aged 12 to 45, right? So in other words, what we're almost thinking of is women aged 12 to 45 are the typical age for childbearing. So if will women continue to have the same number of babies, right? We're trying to see if that's proportional. And if you think about this for a minute, that's going to be no, right? And actually one big driving force of one variable if for the number of kids that families typically choose to have, deals with the economy, right? So if we have like a recession where the economy's not so good, you you know a lot of people don't choose to have less children because they don't have as much available resources to provide for another child, right? So things like that um, impact those decisions, right? So this would not be proportional. So we would say no. We could say the number of babies per woman each year is variable, right? So when I say something is variable like this, what we're referring to is meaning it changes. Like constant means it doesn't change. Variable means it does change, right? So we're saying this is variable. It's not gonna this is not gonna remain the same each year, right? So we could say, as I was saying, we could say recessions. For example, results in fewer women choosing to have children. All right, so let's go for number 5. So then number 6. So this is the total cost of buying tickets compared to the number of tickets, right? So if I double the cost of buying tickets, well, the number of tickets I get double, right? And we're assuming that we're all the tickets are the same cost, right? We don't have like different tickets for children or adults, right? We're just saying in general, if I have tickets that cost X dollars, if I double the cost of buying those tickets, will I get double the number of tickets, right? So that's using our intuitive definition, and this would be yes, right? This would be proportional, right? So the equation we could get is we could say the cost is equal to K times the tickets, right? So K, right, would be the constant, which would be the price per ticket, right? And the unit here would be dollars per ticket. Right? So if we don't see that directly, if I solve for K, right, I would need to divide both sides by tickets. So now you can see it's cost by ticket, right? So price per ticket. And cost is represented in dollars, and tickets, the unit, are the number of tickets, right? Good. So the number 7 says the height of a digital photo to the width of a digital photo, right? So let me show a quick example of what we're talking about here, right? So let me minimize this and let's just find a picture of something, right? So let's say a brown bear. All right, so I'm just going to grab this picture. We're going to copy it. So copy image. Then I'm just going to open up a Word file. And paste it into here. All right, so you've probably worked with pictures and Word files before. And I don't know if you've always been taught, right? But if I drag and move from the corner, then what happens is there's something locked in called an aspect ratio. It keeps the same length and width ratio, right? And it doesn't distort the image by doing so, right? So if for example, let's say I want to make it really short without using aspect ratio, I could use this middle one here and just drag it down, right? And if you notice, my image is distorted, right? It doesn't look how it used to look, right? So if I undo this, you can see how different how different those look, right? It distorts the image. Doesn't keep the same image, right? So we're talking about this idea. So let me go back to the OneNote. So yes, this would be also another application of proportions, right? So here we're assuming we don't want to distort the picture, right? Right, because again, we're giving this an application, right? There really isn't many times you'd want to distort a picture, right? So it makes sense just to assume that we don't want to distort the picture. So the equation we could get here is we could say height equals the k times the width, right? So k is my constant, and I said this earlier before, but in the IT world we call this the aspect ratio. Aspect ratio, right? And so typically the width is measured in inches, and same with the height. So if I take height divided by the width, right, what I would be doing in my units is taking inches divided by inches. So remember, if we take the same unit divided by the same unit, those cancel out. So this would be unitless, right? So if all my units go away, we call that unitless. Okay. So then number 8, we're told the number of accidental deaths in 2005 compared to the number of motor vehicle deaths. So again, if you think about this for a minute, this would be no, right? So we would say no, and you could say there is no reason the total accidental deaths must double if the motor vehicle deaths double, right? So you can fill that in, right? So there is no reason the total accidental deaths must double if the motor vehicle deaths doubles. Right? No reason that must happen. So then number 9, we're comparing cups of sugar to cups of flour in a pancake recipe, right? So yes, this would be proportional, right? If you don't keep this proportional, then you won't have the taste be the same, right? And that doesn't seem practical either, right? So if we're doing a pancake recipe and comparing cups of sugar to cups of flour, and let's say maybe I have, I don't know, double the amount of flour I need and I want to use it up, then I would also have to put in double the sugar, right? So this is proportional. So we could say the sugar equals K times flour, right? And K wouldn't have a specific name here, right? It's just the constant proportionality, right? It doesn't have a special name. But to get K, I would need to take sugar divided by flour. So this would be in cups divided by cups. So this would be unitless, right? These cancel out, so we get unitless. Right, so we could say that K is unitless, but we don't have a specific name for it. Right? Number 10, so we're comparing your IQ to your GPA. You know, does this seem to be proportional? So if you double your IQ, does that mean your GPA is going to double? And this would be no, right? So we could say no, your GPA may double due to just doing the work. Just doing the work. Right, so you could go from a 2.0 GPA to a 4.0 GPA, and your IQ doesn't necessarily change, right? So there's other factors than just IQ for GPA. Let's see, 11 is distance to work compared to the time it takes to get to work, right? So here we're assuming that you're going the speed limit, right, the whole time, right? So you're going a constant rate over the same, you're traveling at a constant speed, right? So for example, when I drive to work on 309, right, I go 55, right, the whole time. So we're assuming that type of scenario. If that's the case, then yes, this is proportional, right? So the equation here we could use distance equals rate times time, right? That you're used to seeing, right? Where the rate here, this is my k, right? So k, the constant proportionality is the rate. So k equals the rate, which is in miles per hour, right? Is a common unit for that, right? So then number 12, I'm just gonna skip, right? It's a good example, but I'm not assuming that you have familiarity with celestial objects and so forth. So we're just gonna skip 12, right? So if we jump down to number 13, we're comparing euros to dollars at an exchange booth, right? So in other words, if I take €1 and exchange it for dollars, right, and I have that rate, if I double the euros, would the dollars also double, right? So if we think about that for a minute, yes, that would also be true, right? So yes, this is a proportion, right? So we would get E equals K times D, right? So E for euros and D for dollars, and K would be my exchange rate, right? So that's what that's referred to, and the unit would be euros per dollars. Right? So then, lastly, number 14 is the miles you drive compared to the gallons of gas used, right? So yes, this would also be an appropriate scenario to use a proportion for, right? This is proportional, right? So if I double the amount of miles I drive, I'm going to double the gallons of gas I used, right? And this is, again, this would be assuming that we have constant gas mileage. So constant gas mileage is assumed, right? So if we're getting constant gas mileage, so for example, if I'm driving at 70 miles per hour on the highway, and I want to compare how much gallons of gas I'm going to be used, right? Maybe I already know the miles per gallon that I get if I'm driving 70 on the highway. Then I could use that and use that as set that up as a proportion, right? To figure out how much gas I needed to buy to travel from here to New Jersey, for example, right? So forth, right? So that could be a very good tool. So the equation we could get is distance equals K times G gallons, right? So if I divide by K, I would take distance divided by gallons. So a typical unit there, we could do miles per gallon, right? All right, so that's all I have for this worksheet. Thanks.